This video demonstrates the tools available in PowerFactory for carrying out arc flash calculations using the industrial network example. For arc flash analysis, the network elements first have to be populated with all the required data. Let us look at one of the busbars in the network as an example. On the arc flash analysis page, we see that the attribute accessible location is selected, and that the relevant data have been entered. The arc flash command is found here. The analysis will run short-circuit calculations as specified in this command. The calculation method has been selected. And on the advanced options page, we can see the input parameters such as the PP categories according to the calculated incident energy levels. Back on the basic options page, there is an option to specify the arc duration, using fixed times or according to the relay tripping times. To start with, we will use a fixed time of 0.1 seconds. The command is executed, and the report generated. Sorting by PP category, we see that there are no major problems. Results can also be viewed on the graphic, or in a network model manager. For a more realistic calculation, let us now select the option to use the relay tripping times for the arc duration, and run the calculation again. Now we can see that there are some busbars where PP category 3 or 4 is required, and some where the incident energy is too high for the available categories of PPE. Note that it is also possible to run the arc flash calculation for a single busbar. Let us do this for busbar 3 as an example. For this busbar, arc flash analysis has determined a fault clearing time of 0.92 seconds, and a PP category of 3. One way of improving this situation is to reduce the fault clearing time. Let us look at the time over current plot for this busbar. We can see the characteristics of the relays around the busbar, including the busbar protection relays, with their fault clearing times of 0.92 seconds. Let us run a short circuit calculation for line CE1. The downstream relay on the line has a fault clearing time of 0.755 seconds, and the upstream relay must have a fault clearing time of 0.92 seconds, in order to achieve selectivity. The fact that a fault on the busbar will only be cleared after 0.92 seconds, means that there will be high incident energy in this case. We therefore need to find a way to accelerate the tripping time for a busbar fault, without losing selectivity with the downstream relays for line faults. We will introduce a third instantaneous overcurrent protection level in the upstream relays, controlled by an interlocking scheme. This will have an additional relay, for the purpose of signal comparison. If we change the study case time, the relevant expansion stage is activated, and the interlocking relay is introduced. Now, if a short circuit is executed on line CE1, all the relays will act as before. But if a short circuit is executed on the busbar, the upstream relays will trip as fast as possible. In the case of a line fault, the new relay generates a blocking signal to prevent this fast tripping of the upstream relays. Let us look at how this works. The interlocking relay makes use of two DSL models, a send adapter and a receive adapter. The logic is as follows. These are the relays involved. A signal is sent sequentially from each line relay to the next, and then to the relay at the busbar switch. The signal is received by each of the upstream relays. If there has been a line fault, the fast tripping of the upstream relays is blocked. Let us run the arc flash calculation for busbar 3 again. We can see that the PP category is now determined as 1, as the incident energy is lower. Let us run the calculation for all locations again. The arc flash reports command, which is used to create the tabular report of results, also has an option to generate arc flash labels. The location for the labels to be created has been specified, so the command can be executed. A Word document is created, and the results exported into Excel. The last step is to apply the results to the labels. Once the results have been applied, the labels can be edited, saved, and printed.